Hi everyone, here we are going to see about the unit 5 continuation. Let me see with the one by one. So this is a TMS 320 C25 functional diagram. So we have already know that is the digital signal processing are having the so many functional diagrams. So in this now we are going to see particularly for TMS 320 C25 are functional diagram. So that is here it is shown that here we we have used the bus structure, central processing unit, central arithmetic logic unit, etc. So that is the bus structure will be having the separate program and data buses in the advanced Harvard architectures. So that is the processing power and provides the high degree of parallelism. It has 4 buses, that is the program bus, program address bus, data read bus and data read address bus. So next is the central processing units, that is the central processing unit consists of ALU, PLU, ARAU, memory mapped registers, program controllers. So the central arithmetic logic unit that will be having the 16-bit cross 16-bit parallel multiplier, and it is capable of computing as a signed or unsigned product in the single machine cycle. Next 16-bit temporary register that will hold the one of the operand for multiplier, and the product register holds the product. 32-bit ALU and accumulator implements the wide range of arithmetic and logical functions. So next we have seen about the parallel logic unit, that is in the second logic unit execute the logic operations on the data without affecting the content of the accumulator. Next is the auxiliary register. So that is the AR file is connected to ARAU and it is used for indirect addressing of the data memories. Next, memory mapped register, that is it has a 96 register mapped into 0 to 511 of the data memory space. So it contains various control and status registers including CPO, serial port, etc. like that. Next is the TMS 320 C25 key features. So its key features are that first the interrupts have been passed into the data RAM and data or program memory. So the data RAM should be in the size of 288 into 16 memory size, and data or program memory should be in the 256 into 16 memory size. So here the data output has been given. So plus 5 volt as the input and the ground also given to the method. So after that it should be converted to 4K into 16 program read-only memory method. After that it will be passed into the 32-bit ALU, that is the arithmetic logical unit, or store in the accumulator. After that passed into the 16 cross 16 multiplier, then it should be given to the address 16. Serial interface should be connected between the ALU and the accumulator. So it should having the 100 numbers ns of instruction cycle time and 128K word total memory space, 3 parallel shifters and 133 general purpose and Dtsp instructions. So S bar W were upward compatible with the previously family members. So that is the 1.8 micro CMOS 68 pin PLCC or PGA. Here is the program, that is when we are passing x is equal to x minus y, it will be sent into the bit 16 equal to 0. After that, if it is yes means the output x will be given, and if it is no means again the processing will be calculated, that is x is equal to x minus y. Again and again the repetitions will be done. So comprehensive instruction set, that is 133 instructions including numerical is 34 and logical 15. So memory management 33, branches 20 and program or mode control will be 31. So extended precision arithmetic, that is the serial port double buffered static. So multipurpose multiprocessor interfaces concurrent DMA global data memory block moves the up to 10 words or seconds on chip timer and 3 external maskable interrupts power down mode also applied. Next, TMS 320C25 ALU's processor, that is arithmetical logical unit processor. So in this processor, that is we have seen that multiplexer has been used. So that will be maintain the multiplying path. So here the design operation should be maintained 32-bit ALU and accumulator, and it should be having the carry bit for a extended precision, overflow detection and saturation, then sign extension option, 16-bit parallel shifter for loads and arithmetic ops, next shifters on product register output data, and 0 to 7 bit parallel shifter for accumulators to store the data values in the multiplier. Next, TMS 320C25 multiply instructions group. So here we have used the data buses. The data buses will be passed into the register and then passed into the multiplier. So here we have used two registers. There is one is 16-bit register and another one is 32-bit register. So both are combined together and form a multiplier, form a multiplication process, and then passed into the multiplier. After that, it has been given and stored the values into the A and B as a arithmetic logical unit, and then that part will be gives the output to and stored in the accumulator, that is the accumulator high level as a 16-bit and accumulator low level in the 16-bit. So if it is a carry we received, means that will be stored in the carry bit. So the MAC program means that is the MPY data memory program is used, and memory and add post accumulator, that should be P to P register to accumulator. So MACDE, that is MPY data memory program, memory add post, that is a P register to accumulator and move the data memory here. So SQRA means that is a square data memory value and add post P register to accumulator. So SQRS is square data memory value and subpassed P register from the accumulator value. Next is the special purpose features. So XI has been given, that is Z1, Z inverse, Z inverse, Z inverse. So 4 Z inverse has been multiplied together and gives the additional process and then pass into the YI. So single cycle or a multiple accumulator accumulates the level and then multiplies the accumulator using the external program memory. Repeat the instructions and then adaptive filtering instruction has been used. After that, the adaptive filtering instructions used, bit reverse addressing mode has been passed. So the automatic data move in memory is the inverse. So 0 to 16-bit scaling shifter is signed or unsigned, and the overflow management is occur. Then saturation mode, that is a branch on, and overflow product right shift is done in the special purpose features of the TMS 320C25 processor. Next, higher performance at a less code space. So when we are passing the X values, that is passed into the Z inverse, that is the transformers. After that, that should be multiplied together and forms the output as a Y of n. So that is Y of n is equal to summation k equal to 0 to n bk into x of n minus k. So here we have used the TMS 320C25 processor. So that will having the RPTK49 MACD processor that stores the 3 words program memory here, 53 cycles. Next, TMS 320 is addressing modes. First thing will be the immediate addressing modes, and it having the short constants, that is both long and add k, add lk. Okay, so that is the programming memory have been stored together and process the immediate addresses. Next, direct addressing modes. It should having the 9 bits, that is the 512 banks of 128 words. So it is used often for the long sequences of inline code. So that is 9 bits for DP, and from instructions it is 7 bits. Next is the indirect addressing modes. So that is B auxiliary registers. So often in program program loops with the auto increment or decrement options is used. So that is it should be passed into the operand addresses. Next, circular buffer addressing modes. So circular buffer addressing modes means that it should passes the values into the accumulator processing. So that is it should buffer the values and then pass the value single bit into the multiple bits. So here we have used the adaptive levels of methods. So that is the circular buffer should processes the instruction set to move the control part of the instructions. Next the thing will be the bit reversed addressing modes. So the bit reversed addressing modes means that we have to reverse the values, and when one value is passed means it will be reversed to another value. So likewise the reversible processing should be done in the bit reverse addressing.